Hello there. This is the last day for section 5 of chapter 1. We're still solving equations with rationals, but today they're word problems, and don't let that strike fear in you because they're not that difficult. We'll start off with some easy ones, and actually I think the last one will still be something that you can do. So the first thing you need to do is if you write the problem, when you read the problem, make sure you know what your numbers are in terms of constants. Make sure you know what your variables are, and try to put together variable expressions and create an equation. So the first one is 8 more than my number equals 23. So I think the first thing you'll notice is the word equals. That's a great, I guess we'll call it like an anchor or a landmark. We all know what that means. So that's equals. Now what we want to figure out is what's on the left side and what's on the right side. Now the name of this section is solving equations, so that means you're going to have a variable on one side and a constant on the other, and then we got to solve it. So let's start with 8 more than. Well, more than represents addition. And here we have my number. Well, my number can be anything. And how do you represent a number that could be anything? You use a variable. Let's use the letter V for variable right now. So 8 more than my number. So my number, and then 8 more than that, equals 23. And there it is. V plus 8 equals 23. This is a simple little one-step equation. We want to isolate our variable, so we're going to do the opposite of adding 8. We're going to subtract 8. So V plus 8 minus 8 equals 23 minus 8. These are opposites, leaving you with V, and 23 minus 8 is 15. Alright, let's try another one. 12 less than 4 times a number is negative 4. So the word is jumps out at me. That's my equal sign. I'll put 2 lines underneath that actually, just sort of emphasize that. Now what we have is 12 less than 4 times a number. And that number can be anything. So I have 4 times a number. So that's going to be 4m. And then it's 12 less than that. So that's going to be minus 12. Is equals. And then we have negative 4. And now we have a two-step equation. So we want to get 4m by itself first, so that variable expression needs to have a plus 12 here. So we're going to have 4m minus 12 plus 12. Over here we have a negative 4 plus 12. Hopefully you're internal warning systems going off. I'm concerned about that part. So negative 12 plus 12 is 0. That'll leave us with 4m. And negative 4 plus 12 is, I was hoping you're saying this in your head, 8. That's just 12 minus 4. 4m equals 8. So let's divide by 4. This is how we're going to end up with m by itself. 4 over 4 is 1. 8 over 4 is 2. So there it is. Let's try this one. 1/4 of a number is 7. Just so you know, this can be shown two ways. So 1/4 of a number. Well, 1/4 and is should be sort of jumping out at you. 1/4 is a fraction, so that's 1/4. Is your equal sign, and it is 7. So then the only other thing we have to do is come up with a variable, because it's 1/4 of a number. So 1/4 of, let's say, z. And there it is. And all you have to do is multiply. Again, we did this yesterday, by the reciprocal of 1/4. So 1/4 times 4 over 1, z, is equal to 7 times 4. 4 over 4 is 1, leaving us with z, and the product of these two factors is 28. Now, I did mention there was two ways to show this, and I'm going to show you the second way. If you wanted to, this z could be on top of a 1, and so you can multiply straight across. 1/4 of a number is 1/4 times z. It could also be a division problem. 1/4 of a number could be 1/4 of a number. We emphasize often that of means multiplying, but at times it can also represent division in this case. And this part is still equals, and this part is still 7. And actually the work after this is identical. We have z to the 4th, z over 4th, and we're going to multiply by the reciprocal, which is 4 over 1. 4 over 4 is 1, leaving us with z, and there's 28. So there's that versatility in math that I really like. When you do yours, if you ever see something with a fraction like this, pick and choose which one you prefer. Now, I got one more to do here. This one's a little bit more of a word problem, more than those were. Naima multiplied his age by 7. Then subtracted 50 Oh, excuse me. I apologize, I missed a whole step there. I know, you're probably moaning right now. Naima multiplied his age by 7, added 15, then subtracted 50 and ended up with 0. How old is Naima? Well, let's think about this. His age is unknown, so we'll just use n for his age. It said that he multiplied his age by 7, so that's 7n. He added 15 to that, and then subtracted 50, and ending up with 0. So let's do some order of operations. We've got 15 minus 50. Let's go ahead and do that real quick. If you have negative 35, that's awesome. This 0 might be throwing you off, but remember, that's what it says. He ended up with 0, so that side is going to be 0. Normally we'd never have that. And we want n by itself, so our second step towards that would be to add 35 to both sides. So negative 35 plus 35, and then 0 plus 35. 0 plus 35 is 35. And over here we have 7n. Then we want to divide both sides by 7. And so how old is Naima? Well, Naima is 5 years old. And I got to tell you, this problem is impressive for 2 reasons. It's a good word problem. It's got good math to it. And I think it's really impressive that Naima, at 5 years old, was able to do this. So, good luck on those word problems. If they're a challenge, just fight through it. Don't give up.